So it's recording. All right, I'm going to share the screen. So we should be sharing now. So I'll begin, as I said, I'll kind of on the video repeat what I just said. So again, a very important thing, exam 1 is next week, right? So we are currently on week 5. Next week is week 6. The exam, you need to attend class. It'll be on Tuesday, so a week from today. You'll have the whole period of time. You can expect about 10 problems or questions, that kind of thing. Some could be as simple as essay type questions, or it could be multiple questions in there. That's possible too. It could, maybe I'd have a cron set of problems and there's 2 or 3. All right, access control things, anything that we've covered from the start of the semester until today. The exam is closed notes. You're only allowed 1 cheat sheet, right? So an 8.5 by 11 page, you can write whatever you want on it, code examples, anything that you want. But just you're only allowed 1 cheat sheet for the exam. Okay, so we'll do that. Any questions about the exam? All right, so this week we are covering, as I said, we're starting as week 5. We're basically done with like the basics of Linux. So at this point, you guys know how to navigate through the file system. You know how to run a few commands here and there, and you have a sense of how it works. You know how to do a little bit of scripting, right? So we've done that basic intro. Now we're going to start going into the more networking portion of the course. Just as it relates to Unix and Linux. So basically, we're going to look at a few things. Today, we're going to start. We can't cover all the services, obviously. It just wouldn't be possible. But we are going to cover some services in this course, and one of them is DNS. DNS is actually, for some reason, if you look at any Linux sysadmin books, there's like a really large chapter in there. So anyway, it's the internet, right? So it's really important. Probably has to do with there's a lot of configuration. So yeah, so this is the topic that we're going to cover. Also, I'm going to introduce Scapy, kind of show you how we're going to do some tricks with it, and then overall how we could actually, you could use it for the lab even although we're going to have a couple of tools. All right, so I'm going to go ahead and just go to the module here. So as you can see, exam 1 will appear here. Oops, sorry. Exam 1 will appear here next week. This is the topic that we're covering, DNS. Okay, I have provided a few files here that you're going to need for the configuration. So this is a configuration and then problems lab. So there's actually 4 problems. So I haven't created the link yet, but the link will have basically this description here. So I'll provide a PDF for this that you have to follow, and I'll talk about that. So as I said today, I'm starting with the lab assignment, and then we're going to get into like the PowerPoint and things like that. This is a longer topic. So now that the topics get a little bit more involved. Okay, this is you will have at the end of the semester, there are 2 mini projects instead of 1 large project. And the mini project, as you might imagine, requires configuring something in Linux. Okay, so I think of what, and that's something that everyone has to configure. So I pick something to configure that's complex. Obviously, it requires a lot of things. And then also there's a more open-ended mini project as well. So, and so this one, what I usually call this is like the mini project, but easier. Okay, this one here. Okay, so how is this going to work? So basically, it's got 2 parts, part 1 and part 2. This will be your assignment. Because it's a longer week, we're going to be on this topic this week and the Thursday of the exam week. So weeks 5 and 6, we're basically going to do this DNS lab. So this assignment is not going to be due until a week from next Thursday, okay? So on week 7, basically. All right, so what are we required to do in this lab? We're looking at the DNS topic from the perspective of Linux. So that means that we are looking at how to configure or how to turn basically our Linux machine into a DNS server. Okay, so we need to have a sense of how that works. You guys have taken your networking courses, so you have, you understand what DNS is. I'll do a quick review of it. And then basically, mostly because this is a sysadmin class, we're just, we're not creating a DNS from scratch or anything like that. We're going to use the well-known, very powerful DNS service in Linux. Okay, so I think I've mentioned this before. There's a very interesting history of Unix and everything. If I have time at some point, I'll cover that a little bit. But in essence, Unix was like, first it was great, but they couldn't really find a use for it, right? And then eventually people started to make it into an Apache web server and started serving websites. So the internet basically, it's kind of what made it very popular. And it's, it's a really important link to Linux. Okay. All right. So that's a service. DNS is another service that Linux can provide. Okay. So usually in your, in your place, you're going to have a domain of some kind, and then you're going to have to maybe set up a DNS server. So that's kind of what we're going to talk about today. So this lab has two parts. The first part is basically part one, configure the DNS server, which in this case is called bind. All right, that's the actual service, like Apache 2 is the web server for Linux and so on. All right, so you're going to have to configure a DNS server and a DNS client. What does that mean? It means that you're going to have multiple VMs, okay? In this environment, I don't know if you guys have already started to set up your multiple VMs, but you're going to need to have that. So really, honestly, you should have 3 VMs just so you can see the whole thing from the perspectives. However, you can do it with two VMs as well. Okay, so it's entirely up to you. I'm not really, but as long as you do the problems correctly, it's fine. Okay, so you're going to set up a DNS server and a DNS client, and this is just like you learned a web server and a web client, right? So on a web client, what do you have? A browser, right? And then the web server is just a thing that's running on port 80, etc., and serving websites. So in the case of DNS server, same idea, but now you're going to have name resolution, right? So we're going to look in the slides in a second. The DNS basically does the name resolution to IPs and so on. All right, so the idea is you're going to have to configure so you're going to create 2 VMs, right? So they have to be, they have to get individual IP addresses. So you have to have one with one IP and one with the other IP. Note that in VirtualBox, sometimes you get this error having the same IP on 2 VMs. Okay, please check the documentation that I provided on the website. I have all the links there and FAQ and everything. Of how to set up 2 VMs. I think there may even be a video of how to set up 2 VMs. Remember that when you can clone one, right? Or you can, but just make sure that you're going to get the 2 IPs. You're going to have to use the NAT network, basically. Once you get them configured, you should IP config and ping from the machines. I'll demo some of these things as we start getting into the lab, but I want to state this. And you guys, if you want to get started, you can. Okay? Any questions about what I just said? Thanks. All right, so this is important to have the 2 VMs for this to work because, oh yes, please.
So for the client VM, does that have to be a Linux-based OS, or could that just be a Windows VM?
Yeah, it's probably, well, the instructions are for Linux, so yeah. So use both seed for client and seed for for the server. Yes, Linux Ubuntu in this case. I haven't talked about the instructions, but you have it's like a tutorial, so you can just follow. Yeah. All right, so we'll talk about that. So that's actually not hard to do. It is, as I said, the mini project at the end of the semester will be similar, a configuration of a service, but a little bit harder. So this is like your practice, if you will, of starting to configure Linux. Keep in mind, in this one, I provide the documentation. In the mini project, I will not. So I will just say, set this up on Linux, show that it works by running some problem, something like that. Okay, so yeah, so good question. but you can do just two Ubuntu VMs, one DNS client and one DNS server. So I'll mention that in a second. And the idea is basically DNS client, right? You'll use a browser, it'll try to do, you'll try domain names, etc. And it'll need to resolve the IP address, right? So we're going to talk about how Linux handles that with etc host first, and then how it can be configured to use a DNS server. Keep in mind the school also, when you connect your VM, downloads its own name server. So that automatically will overwrite certain files, right? So we need to bypass that. Okay, so we'll talk about that. All right, so the first part is really just configure it, bind using dig, which is one of the commands that I believe we mentioned already in the Linux examples. And you'll start to use it. So I'll show some examples today of how you can use it. And then after you've configured the client and service DNS architecture, then you're going to do part 2, which is basically complete 3 problems, okay, as described during the lecture. Okay, so the 3 problems are basically showing the functionality of DNS, right, between the client and the server. Here, it might be the first time that you start to use Wireshark in this class. So you're going to have that in the background so you can start to look at the packets, what they look like. And that's the whole point of it, just to get a feel for what's going on behind the scenes. Okay, so problem 1 is like super trivial. It's very easy. The etc host files, and I'll talk about that. Then you'll have 2 problems. Problem 2 is you're going to disable the DNS server, and you're going to set up an attacker to respond to client DNS queries. So basically, you're in the browser, the client is saying, who is this domain? And it sends that packet, right, to the DNS server, but the DNS server has been taken down, possibly by a denial of service attack, something like that. And then the attacker is going to try to respond. So the attacker is going to try to respond. All right. Better? Yeah. All right. And so, so that's the idea, right? So we're going to disable the DNS server, and then we're just going to set up some code. We're going to do this in Python or NetWalks or some tool. And that's the whole point, that you should start to understand how to manipulate packets, how to view packets with all the tools that we have available. I will also start giving you the reading assignment for Wireshark, okay? So remember that. So probably this Thursday, I'll give you the first reading assignment. Those are pretty easy. You basically just read through it, and there's like some PCAP files associated with those. You load them on Wireshark, you read it, and then you just write a 1-page summary, okay? But I'll talk a little bit more about those later. It's just we're getting into the networking part, and so there's a lot of reading, basically. About cases. It's like cases, this happened. Why is the printer slow? Well, we captured these PCAP files, and then you can look at the PCAP files, and maybe this gives you some idea. All right, so that will be the approach. All right, and then problem number 3 is called DNS cache poisoning, and it's now the DNS server is going to be active, but there's going to be an attack that's going to poison the cache of the DNS server so that when DNS client queries DNS server, it gets an incorrect response, or that attackers, man in the middle or something like that. All right, so anyway, so this is what your lab is going to be. You have some time, right, to start working on it. There's quite a bit going on here: configuration of VMs, learning a lot of new tools, and just getting a little bit of background on DNS itself. Okay, so yeah, so I wanted to talk a little bit about that. All right, so now we can go back to the module here. So as I said, so I've talked about the problems. I will create a link, maybe a Word document or something. There's some files in here. You can see this one. All right, these files, it's important that you use those files when you in a part of the configuration. And there are some files where you may want to start typing things, but the problem is Usually I have found that students make mistakes when they're typing that information. It's very difficult to see. And so I would suggest when you see these files, it's better to just download them and use them in your configuration. Remember that in Linux, everything is a file, basically, right? And so you guys will be doing Linux configuration of something a little bit more complex. I believe this is the Word doc actually for the problems. So I was looking at it. Yeah, so it's the same. It's just a summary. This is not going to change. You know, there's, yeah. As I said, there's no scripting in this lab that's required, although that's what you will be using because you have to achieve the task, really. All right, after that, I have these PowerPoint slides and some of my notes. So these two are kind of a copy of each other. This is just more PowerPoint, and this is more like my handwritten notes. I will start with this, though. This is the PDF of the actual lab that you have to do. Now, you don't have to do this whole lab. There's only, 3 problems because it goes very deep into a lot of different kinds of attacks. And as I said, we're not going to get into attacks. We just want to understand how DNS works, how to configure it in Linux, and then get a sense of the movement of the packets, okay? But I will open the documents as a PDF document here. And so we can take a look. So this one is called Local DNS Attack Lab, okay? So there's the lab overview. Now these labs use Docker. So you might see some information on Docker here, I believe. Maybe not. Okay, this one doesn't have Docker, so good. All right, we will cover Docker. That's actually one of the main topics of the course, but just not right now. So good. So there's no confusion there. I didn't see anything on Docker. All right, you don't need Docker for this lab. Instead, what you do need, as I said, is 2 VMs, okay? The 2 VMs with 2 different IPs that they can ping each other. So the lab overview, you can see that there. DNS stands for the domain name system. It is basically that you can think of it as the internet's phone book. It translates host names to IP addresses and vice versa. This translation is through DNS resolution, which will happen behind the scenes. DNS attacks manipulate the resolution process in various ways, and so we will explore that. And it's with the intent to misdirect users to alternative destinations, which are often malicious. So the objective of this lab is to understand how such attacks work. Students will set up and configure a DNS server, right, in Linux in this case, and then they will try a few attacks just to get a sense of how DNS actually works, the packets, right? So that's really your goal, is to explore, although you should make the attacks work. The difficulties of attacking local victims versus remote DNS servers are quite different. So we are only focusing on a local DNS server in a company and nothing from the whole internet or anything like that. All right, for that, there are other labs, but that's more for network security courses. So this lab focuses on local attacks. The lab covers DNS and how it works, right? So we'll cover a little bit of the background, just as a review. DNS server setup in Linux, which is really the very important thing. As I said, the instructions are very clear, but you should pay careful attention, right? With a lot of these Linux configurations, you need to concentrate because if they're very sequential, right? And if somewhere you made a mistake, you'll get to the end and it won't work, right? Remember, it's text-based files. You could have a little typo somewhere and nothing will work, right? And so this is the whole process with Linux. You have to just get used to it. Now, there's not a lot of installation of tools. Basically, you just need bind9, and then you'll configure the files. Where would the configuration files be located? Probably in etc, right? It's something that you should start to become familiar with. So yeah, so DNS server setup, that's part 1, as I said. And then the part 2 is DNS cache poisoning attack, some spoofing. We will, as I said, as you can see, as part of the lab, we will start looking at packet sniffing and spoofing. And that's just a concept, I guess, in network security, which basically means that you're in a computer like Linux and there's network traffic, right? Everything that's happening in the background is packets. So sniffing just means that you grab the packet, and you break it into the headers and then you look at the information. That's sniffing. All right, so this is going to take us back to our IP, TCP, right? So all these headers, so that we can break them up, look at them. Spoofing just means you grab a packet, you make a copy of it, you change some parameters, send it back out into the world, right? So that's spoofing relates more to the attack. Sniffing would relate more to like eavesdropping or scanning even, because really TCP dump and Wireshark sniff packets. Now, as you can see, the last item is the SCAPI tool. So we will start looking at that one just so that you're familiar with. SCAPI is a tool you'll be using in other courses. So remember, this course is a lot of like background for a lot of other courses that you'll be taking. All right, so I will take a look at that as we progress. Okay. Any questions so far, guys? No questions? All right, great. And then, yeah, as I said, all of it is in the Linux environment. So here are the instructions for setting up a local DNS server. So this part, the main purpose of this lab is on DNS attacks and attacking the local DNS server. Obviously, and I should state this, it is illegal to attack a real machine. You will be learning some tools like netwalks or creating these packets. You could send a lot of packets into our school's network. Don't. All right, or anywhere else. So, all right. Yeah, so please don't do that. The lab environment in theory should require 3 separate machines, but I get that's a lot of RAM for some of your computers, so at least 2 should be okay. One, definitely keep the DNS server like its own machine, right? And then the client doesn't really matter that much, but the DNS server is really important. So the lab environment needs 3 separate machines, one for the victim, one for the DNS server, and the other for the attacker. So you can run 3 virtual machines on VirtualBox. So they can all be the Ubuntu seed VM. That's not a problem. Just make sure you can ping and get that IP. And I provided all that documentation. If you're using VirtualBox, use the NAT network. So you guys all set this up at the beginning, I believe. Remember, there's a NAT and a NAT network. Okay, so NAT network is definitely the way to go. Yeah, so put the VMs on the same network so you can see basically they would have IP such as these, so 10.0.2.18, 10.0.2.17, 10.0.2.16. Should log into all these machines. You can check all these parameters with ipconfig. This is one of the commands that we've already discussed. And then ping, basically, just like in Windows, you can ping things and take a look. I think I have 2 VMs, right? So I will show you guys my setup, and so we can play with that. Okay, any questions so far? That's just a lab environment. Okay, then now, as I said, I'm just talking about the steps here. So you'll have in configuration, you actually have task 1 and task 2, and that's because you have to configure the DNS client and the DNS server, right? So DNS client should be easier. Okay, you can read through these instructions here. Okay, and basically that, as I said, just read through these carefully, and it's very well documented, so you should not have any issues. DNS server, right? This is when you're gonna configure the DNS server in Linux, effectively making your Linux server into a DNS server, right? Now the daemon is called bind. So as you can see, it stands for the Berkeley Internet Name Domain. Remember that the history of the internet is was very like a lot of research groups in the beginning, right? So the whole TCP/IP it, you know, has a very interesting history. It started in 1969 by the U.S. Department of Defense, right? And it was called the ARPANET and all of that. And then a lot of universities were involved, and some universities developed solutions that are still, you know, around today. So, you know, this being one, Bind. So here's a little bit of history there. Yep. So the most widely used DNS server software, you know, for Unix here and probably the world is Bind, the Berkeley Internet Name Domain, which, as the name suggests, was originally designed at the University of California, Berkeley in the 80s. Currently, I believe we'll be using Bind 9, so that should be the latest version. You can read up and see if you can find anything else. Okay, so here are the steps. I'm not going to read this out loud. You guys can read through it, but the information should be very clear. Make sure you read the names correctly. Notice that it's in folders like etc, etc. As I said, look at the names of these files very carefully and make sure that you use the appropriate the two files that I provided on Brightspace. Those are called zone files. And those are important because they provide the mapping. Okay, so I'll talk a little bit about them in the slides in a sec. But they basically are the ones, they're actually that's your DNS mapping from IPs to domain names or domain names to IPs and so on. Okay. And then you'll start, once everything is configured, you'll start the DNS server and you can start testing it, right, to see that it works. I have a few commands on the slides that you may also use to start to get a feel for the DNS server. So remember, if you don't configure the DNS server correctly, then you won't be able to do part 2 because part 2 requires that the DNS client and DNS server have worked nicely. Any questions so far? All right, great. So pretty easy. Yeah, so once you start the DNS server, then you're going to proceed to define the zones, right? So this is the idea of creating the zones. So this part I will talk a little bit more about probably on Thursday. But what's important to note here is that you have what is called the zone and the reverse zone. Okay, so it's really very straightforward. One is the domain to IP, the other one is IP to domain, right? So you might, you know, so it makes it more effective when you're looking at things. So it's like a dictionary and a reverse dictionary. So you got IDs to values or values to IDs, similar idea. It just makes things faster when you're searching. Okay, so you're going to include these two files and then you modify those files basically. So this part here is what's going to be contained in those files, which actually does the mapping. If you notice very carefully, you have here in these entries www and an IP, mail and an IP. So remember that if your domain is example.com, then when you type www.example.com, what that effectively means is you go to example.com's domain and you find the web server www. Do you see that? And then if you had something like mail.example.com, then you're going to that web domain example.com and you're looking for the server mail. So mail.example.com. So basically in the zone, you have mail over here, and then you have the actual IP address that corresponds to it. You will have to change these IP addresses to match your environment, okay? So these are all a whole bunch of services, so you don't have to set all of these up, by the way. But just, you know, map these, because here's the thing, I'm not gonna ask you to send an email, right? I'm not gonna ask you to send an email, but I may ask you, can you please query the mail server for this domain? You see that? So you can query the mail server and it could return something like, you know, 205.215.116.11, right? And you get that that's the IP, even though you did not actually use that mail server. Any questions about that idea? So that's why the IPs here make sense, because you will be querying these, you know, these services that should be running with, you know, these servers, but they're just not running, and we don't need to go that far. Okay. All right, so here's provided some additional information. So I'll definitely discuss some of this in the slides. Okay, and then after that, we will start doing after the configuration is done, right? After you've done all the configuration and everything, then we've got some of the part 2 tasks. And we're only going to do those 3 problems, okay? Nothing more. So here we can see that there's going to be the first problem, modifying the host file. So what is the host file? So as it turns out, in Linux, has a file in the etc folder called host. You can see the address here, etc/host. That file is for DNS resolution. You probably have looked at it before, played with it. So basically, you can set up that whenever this machine is doing DNS resolution, please first look in etc host. So the first problem relates with that file. So actually, there's no need for like the DNS server. You could literally just do it on the client and solve problem 1. But the other 2 problems do require the DNS server, right? So as you can see, this one, spoofing the response to the user, will be the example where you have a machine, your client, which would query something from its local DNS server. Remember that if this DNS server does not have the response, it's going to query out into the internet, right? For the hierarchy. So the problem basically just requires this one to be down. Remember, this is important. You don't have to do a denial of service attack on it. Just turn it off, right? Turn off that machine. And then you're going to I'll show you guys how to do this. You'll set up some either SCAPI or NetWalks as the tools that are going to do the attack, all right? DNS related attack, okay? So this is the directly spoofing response to user. Any questions so far? All right, and then the last one will be, and here there's quite a bit, so we'll come back to these as we start. There's a lot, I know, so we're going to start drilling down to these things. We have about 2 weeks for this, so no problem. So as I said, to do these attacks, we have basically 2 approaches, 2 tools. One is SCAPI. We can use that. Or we could also use something called NetWalks, which you can see over here. NetWalks. This is a command line network attack tool, basically. It's a spoofing kind of a tool. So all these attacks only relate to networking things. They don't relate. So for instance, you guys may be familiar with like buffer overflows and things like that, right? So that means that you have a server like an Apache server, you go send some things through port 80, get into memory, exploit the server, right? None of these attacks are like that. We're not exploiting vulnerabilities of any of these services. That's for other courses. In this class, everything works. Everything is, the servers, all the code is written well and everything. So really what we're going to be exploiting is just creating packets that are not correct, spoof packets. Any packet that you manipulate and it's not a system packet, you can call it a spoof packet. And these are the packets that we're going to be talking about. So that's the NetWalks tool. I'll show you guys how it works. It's pretty straightforward and it's command line approach. And then the last one will be this one, the DNS cache poisoning. So again, remember here, you do have a DNS server active. So in the previous example, we take it down just by shutting it off. But in the last problem, we do not take down the DNS server. Okay, guys? So in that one, it needs to run and the attacker needs to use NetWalks attack, but directed at the DNS server. And then the DNS client needs to query that one, but it's going to get the cache, badly cached or man-in-the-middle entry in there. Okay. For the tools for checking things, we're going to be using basically our simple utilities of ping and dig. Basically, we should be able to accomplish quite a bit with those tools. Any questions so far, guys? All right, making sense? All right, great. So yeah, so that's kind of the idea. On Thursday, I will probably begin with just configuring bind. So I'll go over that. You guys can work with me, right? And we'll try to get bind configured and working. And then we'll maybe do one attack, and then we'll leave the other two attacks for after the final. And hopefully that should be plenty of time. Okay, so that cache one should be, yeah, DNS cache poisoning should be the last problem. If you notice, after this, we have DNS cache poisoning targeting the authority section. So in fact, there are many attacks on DNS. Like this could go for a while, right? So this one we're not gonna do. You guys can do it for fun if you would like, but you're not gonna be doing it. But basically everything in this document until here, you do have to do. Questions about that? Is that clear for everyone? All right, so I'll just show you, but we won't be doing these. There's quite a bit there. So the other thing is, as you can see, you may need to use Scapy for several of these tasks. So I will, you haven't looked at it yet. I will be introducing some of this as we go along during the semester. We'll come back to Scapy every now and then for various tasks. All right. My basic examples this week, starting this week, are very simple. How does it work? What do you do? So basically, how do you construct a packet, or how do you capture packets? Simulating TCP dump or simulating Wireshark. Okay, so for instance here, this is just an example. The following sample code shows how to sniff a DNS query and then spoof a DNS reply. Okay, so that's the basic idea, which contains a record in the answer section. So that's what these packets are about. They're who is, and then they provide an answer. Basically, they're UDP packets, and so they are actually quite straightforward. We'll use, as you can see, Scapy. We need a library called Scapy. We'll probably need to install this one, or it may already be available in the CVM. And then we create a function, just like we saw at the beginning of the semester. And then, just basic things. We'll create the headers. So IP, UDP. You guys know this stuff, right? So a packet. Think of a packet actually as an array. Okay, that's really the best thing that you can do. It's just an array in memory. Okay, a buffer. You'll see probably the term here somewhere in the documentation. That's it. And so you get this buffer, and then you're gonna invoke its Ethernet header, which is the first part, right? And then you have the IP header, which is the next part. And then you're either going to have TCP or UDP, right? For DNS, it's going to be UDP. But for other applications, we may look at TCP. And then after the TCP, we may have a payload for some reason. And so that may also be something that we do, okay? So this just gets into, the various things, of creating this packet. So this is just an illustration, but you can see here we have an IP, the IP header. So it's very straightforward. If we want to, let's say we capture the packet and then now we want to spoof it, what do? We copy the packet and then we just flip, right? We flip the IP, the source IP and destination. So you can see that there. So the source and destination IP address are being swapped. And then we can grab the UDP header, right? And the UDP header will have to do with source port and destination port. Then because this is DNS, now it's going to be specific to that type of packet. So it's going to have an answer section, the authority section, additional sections, and so on. Okay. And then this is an example of constructing the packet. Notice that it's very easy. You create each header independently, like the IP header, the UDP header, the DNS packet, all of this. And then basically you use the / to concatenate them so that you have in order. Okay. Again, this is just very high level, and we will come back to this, but it's just, it's here. Once the packet is created, we have a built-in function in Scapy called send, and boom, we just send it out. Keep in mind, if you do while true, send, you're going to send out a lot of packets. This function also has a counter. You could say 100,000 and send it, right, to the school. Try that. See how quickly they get in touch with you. All right, so so don't do that. All right, so you will for this to work, remember you're gonna have to use the sudo privilege because this function requires grabbing the network interface. So you're going to need to have the root privilege, basically. Once you have the root privilege, you'll be able to send the packets, okay? Now, it's very easy with Scapy, as you probably see. I mean, you have a function usually. The function just takes PKT, which is a pointer to the buffer that contains the packet itself. And then you can do whatever you want in there. It's really, there's no limitations, like up to you. Notice that it's got basically the way of sending the packet and constructing it. And then this one line of code is all you need to sniff. Okay, notice that you put this as, it actually starts here, right? So if you notice, it starts here, you're going to have spoof DNS. And so here's the reference to spoof DNS. So you make a call to sniff, and that's like invoking TCP dump or invoking Wireshark and looking at the packets and all that. All right, so in this case, you have to provide a filter. These filters are actually consistent with the filters that you guys will put in Wireshark. Because there's the funny thing. All of these programs under the hood, if you will, are using CC++. And CC++ has a library called LPCAP. So whenever you use that LPCAP library, the C library for network-related things, it's very powerful. So all these programs are kind of written on top of it, and so that at least, the filters are very consistent, etc. In the Wireshark reading, you'll look at some filters, and so that should give you some insights, at a higher level. So the sniffer here sniffs UDP query packets and invokes spoof DNS. You can see that there. Basically, it only needs a filter. In this case, we're saying that we want this script to sniff UDP packets only and with a destination port of 53. And we'll talk a little bit more about this port number in the slides in a second. And then we tell it as it's sniffing, it's kind of sniffing the environment in a loop until it catches something. When it catches a packet, notice we just specify the function where we want to send this packet to be processed. So that's spoof DNS. So that's the function that we define over here. And notice that by default, it expects the packet to be, that it's going to process. Okay. Any questions? All right, so we'll do some examples of these on the virtual machine in a sec, but I just wanted to discuss that. You can see this has a lot of documentation. Certainly read, please, these documents. As usual with the submission, students need to submit a detailed lab report to describe what they have done, what they have observed, and how they interpret the results. Reports should include evidence to support their observations. So please provide like a screenshot and 2-3 sentences just describing what you accomplished. Evidence includes packet traces, screen dumps, etc. You should also list important code snippets with explanations. Yeah. Okay, please don't just attach the code or something like that. I know the code. I'm giving you the code, so I don't necessarily need the code, but I do need the report that you completed. Does this make sense? So as you can see, this lab is much more involved, but that's why I'm giving you 2 weeks for it. And as I said, it should be good practice to start configuring ever more complex things in Linux. They said at the end of the semester, you can expect some somewhat difficult set of configuration. That's really the projects. It's just like configure the service, configure that service. Okay, questions? All right, so I'm not hearing any questions, so I'm just going to quickly go through the slides that I have here. I'll start with so I have 2 sets here. I have, this is my notes. I'll start with my notes, which is all here in this document. So I'm going to download the slides, which are just like formal PowerPoint. when I use these PowerPoints, it breaks Zoom sometimes. So. And then I also have my PDF here. So, or this is also slides. Okay. So I open the slides. Let me open this one. Okay, both are open now. So I'll just kind of illustrate. This one has a lot of slides. I've kind of summarized this one into the other one. Yeah, hopefully this is what breaks Zoom sometimes. All right, so we'll talk, these are just, the discussion on DNS. So I'll come back to these for some of the ideas. Okay, some of the commands, but I've mentioned a lot of this. Yeah, so I'll leave this as kind of for the end. Yeah, and then let's start with the other ones. Maybe I should have converted this to PDF. All right. So hopefully, yeah. All right. So these are some of the ideas. This is just a quick summary, basically, of things. Yeah. So DNS, managing network services, right? So basically, as you know, resolves names to IP addresses. Obviously, it's more convenient to use names than IP addresses. So the networking abilities of DNS are to translate a host name to an IP and determining the route to a desired remote destination. Domain name system is a facility that provides name resolution in Unix. The implementation is bind, basically. Bind 9, I believe, is the version that we will be using. Bind 9 has two distinct activities. It has the actual host name to IP address translation, and it also includes a distribution mechanism for the underlying translation data. Okay, so it has to be able to talk to other DNS servers. Okay, structurally, DNS is basically a distributed database whose contents are spread across the entire internet, basically, or world, really, with individual DNS servers permanently storing only a subset of data for which they are responsible. Okay, so that's basically it. So it's a query system. The university has their own DNS servers, right? And if somebody that doesn't know the university wants to access here, they'll query their local DNS server. If that doesn't have it, that local DNS server will contact another DNS server until it gets to a root server that will tell it where to go for the information that it's looking for. That's basically what it is. So really, that's why one of the key things in the lab is just to look at these packets for where is, doing the query and the response. That's really what you're looking for. It's like packet going out with the query and then the response. That's really the whole mechanism. So you can see that there. You have queries into this massively distributed database work because DNS has the ability to forward translation requests to the appropriate servers automatically. So you have here A, who sends the little packet to its own local DNS server. If that's not there, then this DNS server will contact other DNS servers, and that's the process until it finds a response. Okay. Okay, the DNS organizational structure defines the domain name hierarchy domain names are arranged within a tree structure rooted in the root domain. So basically like that. So it's funny because we're used to reading from left to right, but really for domains, it's from right to left, right? So you have .com or .edu or .us or .japan, right? So that's basically the first thing. Then you look at maybe Amazon.com. And then within the Amazon domain, you have www.amazon. So that www means an actual server, right? It's not just like a command or something. That's the server in the zone. But you also have, something like ns.example.com, which is the name server, right? For a domain name resolution. You may have a mail.amazon.com, which is the mail server, right? So you're reading it like that or down. So .com, etc. So bind9, which is in Unix, bind9 components, two components basically. The resolver, which is a subroutine library used by commands and user programs. Okay. And this is just other libraries might use it, or maybe like our scripting commands like dig, etc. And then we have the daemon itself, right? So you guys know what a daemon is already, a process running in the background. It's actually called named. So this named, for daemon is what is running. And this service is configured via a collection of ASCII files. In fact, this is what you guys will be configuring in this lab. Zones are really important. So this is kind of the main thing I wanted to talk about. Zones, name servers or DNS provide name resolution services in the form of these DNS zones, okay? You will actually look at these DNS zones, and it's the thing that you will be configuring in the first part. So they're just really text files. That's really all it is, but you have to make sure that you put them in the right place and you put them in the right format, etc. So a zone is just the name given to the collection of hosts within a domain. Okay, that's it, right? So that's one of the, it's a list basically, documented in a text file. Okay, that's it. Sometimes named, this is called a namespace, but basically the idea is a zone is the name given to the collection of hosts within a domain. And that zone will include then the mappings of the domain names to the IP addresses. So here you can see it. I have the IP addresses, and then I use the university's pnw.edu as the domain, and then I have used web, which would be www. MX should be a mail exchanger. Mail is basically another mail server. Okay, and then here you could have NS and so on. So there are various servers that you can have in here, but this is where you would configure them. And as I said, this is what you will actually be doing. So if you set up an email server, let's say you had a fourth VM, right? Then you need to have that IP, and then when you query the domains for mail.pnw, you would get the IP and then go to that server. But in our case, we don't have to configure so many services. Okay, so zones map host names to IP addresses. And there's also the reverse lookup, which is basically the opposite query, IP address to host names. And that's just because it needs to be pretty fast and efficient. Okay, so there's the file and the reverse file base.
Was there a wallet file in here in the last hour or two?
Not that I know of. Okay. It's an important wallet.
Yeah, I mean, it's my wallet, but yeah, just out there.
All right.
All right. Thanks, though.
Yeah, take care. All right. Okay, so so we were talking about zones. Yep. All right. So just a few additional notes for your lab. So bind been around since 1984 in Unix. The master configuration file should be found in the etc folder, right? So by now you guys should start to get familiar with how to configure files. Certainly, I think this lab should help you out. We're going to have several configuration assignments. We need to do Apache and we need to do SNMP. So several need to occur. So it's going to be etc, and then in there you'll need to look for the file name.conf, conf. So that will be one of the files that you need to configure. Syntax in some of these files, there is a syntax to be followed. Notice it's the standard curly bracket and semicolon. Basically, you'll have some kind of a keyword with arguments. This is a comment. So if you notice, it's a / asterisk and asterisk /. This is a classic C++ commenting style, but it mixes it with like the Python one. You can see that there. And then so notice within the curly brackets for a keyword, you establish things like a command and a file. Okay, that's kind of the scenario. So, okay. So for the var named, and then you have a cache or something like that. So this is you probably saw that in the PDF, that some of the files followed this syntax. So you need to basically just modify things and make sure you don't introduce errors. All right, so yeah, so that's basically it. So the problems are going to be, which is what I'm describing here basically. You have the name resolution. So usually you have a client, and the client is going to send out the packet, who is Hamlet, hamlet.com, right? So that's one of the things you can try, right? So this, do dig hamlet.com, for instance. That's the Linux command, but in the background, that triggers the DNS query. So my suggestion for this lab, have like Wireshark always in the background and look at the packets as they're going out and get a feel for them. So the steps in DNS resolution, when such a thing happens, is that first Unix will search a file to see what is the order that it should try to resolve DNS. So it'll start with its local file, which is actually just a text file, and then it can query out into its own DNS servers. So the first step, number one, is to just look at the local host file, which is this one, etc host. Okay, this is just a text file. You guys can, if you just sudo it, you can go in there and put whatever you want and modify it. Okay, if we cat this one, we'll do this when I start doing the demo. Cat etc host, what you will see is something like localhost 127.0.0.0.1. So that's why when you guys open your browser, and if you have Apache and you just type localhost, you get that machine's website. This is what's happening. So you're literally typing localhost and it's just resolving to itself, basically. And that's established here. Okay. Yeah, but you can have other things. So I just provided some examples there, or whatever you want in there. There will be some labs that you have to do where you have to set up some domains, and you can just set them up here, no problem. Once you do the etc host, and that doesn't resolve it, the client can contact a DNS server, like this one. So then you can go to bind, right, and query, basically. So you can see here, this just means the question query going out. Okay. So for DNS client, you also have to configure the DNS client. On the client side, you need to look at the etc resolve.conf file. Okay, when you're doing the client resolution, that should be in your PDF as well. Okay, so you'll have to follow those instructions to configure the name server that you need to do, but it could be as simple as just typing name server and then the actual IP of one of the two VMs that you set up as the DNS server. With one little issue, and that is that you guys have internet access, right? When you start up those VMs, and so you're downloading the school's DNS server. So there's a couple of commands in Linux to kind of disable that for a while. Okay, remember, then you want to probably enable it back. Okay. All right, so here's a few additional commands that might be helpful for you to start playing with DNS related problems. So who is, so remember when I write to symbols like that, I mean the terminal, could be root or just regular user. So you can do who is pnw.edu, okay? The name daemon listens on port 53. So what this means is the DNS server is listening on port 53, okay? On UDP. This, as I said, is a file that you can take a look at, name.conf for configuration parameters. So if you want to find out, so the question here says, how can you find out if bind is running on your Linux machine? That might be the first question you have, right? You might be like, is bind already set up and running, right? So how do you do that? So you by now should probably know that you can do things like PS. These are some flags, AX. This gives you what? The processes that are running, right? So you can do that. And then this is a pipe, right? So you should be familiar with now. And then you can do grep name, right? And that of the output of processes running can check to see if the name daemon is running in the background. So that's a command worth looking at. One of my favorite is netstat-na. So whenever I'm dealing with something related to ports, and services that I want to set up, I like netstat. So I do netstat-na pipe grep UDP. Remember here, we've done TCP, but you want to look at only the UDP services and ports. And as this stated, it should be running on port 53. So if you see port 53 there, you're good. So definitely, once you configure bind on your DNS server, you will have to run this command. Okay, this is the command, and if you don't see it, you did something wrong possibly, so you need to troubleshoot it, etc. Any questions so far? Making sense? No questions? All right. So other commands that we might need to start and stop bind, it's etc init.d bind9, and then here it should say start, stop, and restart. Okay, so these are commands that you might need. To install a bind for some reason is not even installed, then you can do sudo apt-get install bind9. Okay. Okay. Oops, sorry. If you want to look at the order, this specifies the order of DNS resolution, you can go into etchost.conf and just look at the order. So you can see here it says basically that it's going to start with host and then bind. And you can change the order most likely. Pretty straightforward. The dig command. So this one you have already used. I introduced it very briefly. The other set of slides does have more examples of how to use dig. Okay, so you can read through those and basically get a sense of how it works. I'll probably go over those slides on Thursday, right? And today I'll just do Scapy, introduce that one so you can, do something on the VM. Okay, and then I'll kind of recap with the other set of slides on Thursday and then start configuring bind. But basically dig, which you were in your homework assignment supposed to look it up, right? And what does it do? So it queries DNS records for a domain name. So you can do something like dig moon city pnw.edu, right? So specific set of domains, right? So give these addresses of the root servers. You just have to type the command dig itself. Okay. This is a nice example of the reverse lookup. So you might wonder, when would you want to do this? Well, let's say that somebody is spamming, right? You're getting a lot of spam, etc. You just have all these IP addresses and you're like, who is this? Who is this domain? So you can do dig-x and then the actual IP address, right? And look it up. So that's an example of using the reverse approach of dig. All right, that's kind of the whole set of slides, I think. This is just the setup of the lab so that you can have a sense of the attack or the whole lab, really. So let me see if I can move this thing. Okay, great. So here we have, this is the lab setup, okay, for the assignment. Really basically, I mean, if you were doing this 100%, you would have the, 3 VMs, right? We can label them as, in a sense, as client, DNS client, DNS server, and attacker, but they're all the Ubuntu seed 2004. So this is seed, this is copy 1 of seed, this is copy 2 of seed. What's important is they should have different IP addresses, right? One of the first things we will need to do is ping from one VM to the other and make sure that that's working, that functionality. So notice here, there are 192.168.9.134, 192.168.9.132, and 192.168.9.135. So they can be in the same network, all that, there's no issues. So on the client, basically, you have to establish that the name server for it to use is, so if the client is 192.168.9.134, we set up 192.168.9.132 to be its DNS server. Okay, this is one thing you have to configure. So in the DNS servers where you're going to configure by 9, okay? And then in the attacker machine is this 135 is where we would run either SCAPI or NetWalks to create these fake DNS packets. Does that make sense? Any questions about that? Pretty easy, right? Okay. And then here, just remember, this is going to be the NAT network configuration. So I wrote NAT, but really VirtualBox has NAT and NAT network. Use the NAT network. All right. So yeah, so that's basically kind of a review of these. So now I think let me start the share screen again. All right, in the time that we have, I'm going to, oh yeah, sorry. Okay, like I said, I'll cover these on Thursday, these other set of slides. And now let's just start with the virtual machine, right? Let's get some functionality going for this assignment. So I'm going to minimize this one, minimize that one. I'm going to start the VM. Okay, and I do have 2 VMs. So I'll just kind of quickly go over starting both VMs and basically pinging, if config, all of that. All right, so I've got this one. So I'm going to go ahead and start it. And this is sharing already. All right, so I've started one. I think I can start the other one. Same time. Let's give them a minute to load. On Thursday, I'll probably try to configure bind here on this one. And you guys can start now, of course. This one says power. Okay, started. Okay, I think I have 2 VMs. We're starting to have 2 VMs here. Yeah. All right, there we go. All right. Okay, so as I said, we're just going to start with some of the two VMs functionality, and then we're going to take a look at Scapy and a few commands. All right, perfect. Okay, so I have one VM here, so I'm going to log into it. Password should be D's. This other one still working. Mhm. All right, so one seems to be available now, which is this one. Okay, so we've got one virtual machine. I just want to get to the other one. And then we're going to go into devices and just check the network configuration. Okay, so I'm going to go over here, click on devices. You can see that network settings. Okay, and it should say NAT network. You guys should have that. So on adapter one, just click on, don't select NAT, but not network. Make sense? Okay. So make sure you click on that one. In advanced, yeah, promiscuous mode, allow all, so that should be okay. And then, yeah, so that should work. All right, let's take a look at the other one. That should be this one. Devices, same thing. Network settings. Okay. And once again, you need to check NAT network is the one selected. Advanced, allow all. So that should be okay. Okay. All right, so the next, you have two VMs now. So what you want to do, now keep in mind, one common mistake that I've noticed students make is that they see the lab has these IP addresses. So they start changing the IP addresses of these machines. You don't have to do that. Just use the IP addresses of your own machine and change, basically, use those in your configuration. Okay, so let's take a look. So really, I'm going to open up terminals here. I usually like to write this down of the IP, so that's a good idea. Create the drawing basically with the actual IPs. So I'll bring a page on Thursday probably. Let's take a look in here. All right, there we go. So you can do if config, and it should be enp0s3. All right, so this is for Docker. This is the loopback. So this is your actual network interface, okay? enp0s3. You can see this one has an IP address of 10.0.24 with a net mask of 255.255.255.0. So we're good. So 10.0.24. Now let's take a look at the other one. Okay, so I'm going to do one machine is 10.0.2.4. Okay. Now I'm going to go to the other one. Okay, we're gonna do if config. And this one you can see, it's got the Docker, it's got the loopback, and it's got the enp0s3. You can see that the address is another one, and that's what we want. So it's going to be 10.0.2.15. Okay, now you need to ping, make sure that they can't, if you can't ping between them, I mean, nothing will work, right? Your DNS has no chance of working. All right, so let's go ahead and from this one, we're gonna ping 10.0.2.4, right? So I'm gonna just do ping 10.0, 10.0.2.4. Okay, great. So that's what we want. So the machines can talk to each other. I usually just go to the other machine. And really, this is actually what you guys will be doing a lot of the time is like, you know, using the ping command or dig command to actually look up things. And then what you want to see is that this number is going to change. So like in the attacks, right, if you're going to a specific place, you know, you wanted the number to be something. But in your attack, you're going to say, oh, no, send it to 2.3.4.5. And then you would see .2.3.4.5. Even though it doesn't get to that place, it was redirected to that place. So basically, your attack was successful. Do you guys understand? So that's basically the mechanism that we can use to try this lab out at the end of the day. All right, so I'm going to go to the other one. I'm going to go to 10.0.2.4. 10.0.2.4, and I'm just going to ping back. I'm going to do ping 10.0.2.15, and once again. So they can talk to each other, no problems. And so that's really great. All right, so now let's just start with Scapy a little bit. In the time that we have left, we have about 14 minutes left. So let's go ahead and just take a look at some of that. So I'm going to do clear here. Okay, so this is the VM I've been using all semester. So I'm just going to cd, let's see where I am, ls-l. Okay, so I'm going to cd into desktop. Clear. CD. ITS 372 spring 2024. Okay. And I'm going to create a new folder here because this is a new set of examples. I'm just going to call it DNS, you know, and Scapy maybe, right? So that we have something meaningful. So I'm going to do DNS and Scapy. It just has to do with this lab. Okay, so now I'm going to go ahead and just go in there. Okay, so all right, great. So the first thing is, you know, we're just going to start taking a look at Scapy, right, to see if we have it. So we want to think of a script and its basic functionality. Let me. So the first thing we probably want to do is check to see if we have the library available. Okay. Let me do. All right, so remember I have Anaconda install, which is something that I need to get you guys to install. So yours looks a little bit different. I'll be using something, we may be using pip. or we'll use apt-get install. So I'll think about that. Let me see, but just keep in mind some of these commands may be a little bit different. All right, so let's start Python. And I probably have this, I would assume, because I'm sure I've used this. So this, if you remember, is the Python interpreter. So I'm just doing from Scapy .o import all. So we're going to import everything basically. If I do that, yeah, I have it. So you guys should repeat this exercise probably with Python 3, which I think is how you use the command. When you get to 3 arrows, run this, please.
That asterisk stuff there.
Yeah, it's an asterisk. Yes. Yes. Do you guys have it? It gives you an arrow when you do this. Okay. So then we need to install Scapy. Okay. So that's surprising. I thought it was installed on these machines. Nobody has it, right? So probably for you guys. Did you run?
I just did the sudo apt-get to get it first.
Oh, you got it. Yeah. Okay. Yeah. So you installed it with apt-get. Okay. Yeah. So there's a couple of ways, I guess, that we can install it. There should be one way. Let me exit out of here. And you guys can try this out. All right. So you could install it with sudo pip. Because you guys have Python 3, you have to specify pip 3 probably. Install Scapy. That's one way of installing. Okay. Pip is one of the dependency managers for libraries, basically, that are associated with Python. You use apt-get. So in that case, let's look at this. Yeah, maybe the command would be, so this is one approach. Right, so that it I actually don't want it to. And then the other one would be sudo apt-get install Python 3. Yeah. Is this the one you used?
I just did Scapy. I didn't specify.
You didn't specify Python? And then when you did the from scapy.ol import all, it worked?
Yeah.
Okay. Yeah, so try it, guys. I mean, at the end of the day, there's multiple ways of installing things. When you install Anaconda, you could sometimes install with Conda. Other times you do pip, sudo apt-get. I mean, think of it as like there's the default way, and then there's companies that arise. All right, so I asked you the question, were you guys able after installing to get Scapy? Everyone got it? All right, great. So then let's start looking at it. Let's take a look here. So it's possible that we can actually invoke Scapy with an interpreter, right? So let's try that. So I'm going to do here. And if not, we're just going to go into the Python script. But you could try something like sudo Scapy itself. And there it is. So this is just like Python has an interpreter, Scapy itself has an interpreter, but we can also import it into our Python scripts, okay? And so we can try out some of its functionality. We're just really going to look at some basic commands here. All right, so we can do a listing basically of Scapy. You can see it provides basically everything that's available in Scapy. So a lot of this is like network protocols, headers, etc. So all manner of packets that you want to process basically. See ICMP. What's ICMP for? What header? That header is associated with what type of packet? ICMP. Nobody? It's ping. Okay. So you have your Ethernet, you have IP header, and then instead of TCP or UDP, you have ICMP. So those are ping packets. So this is kind of what, yeah. Anyway, so as I said, I'm just listing everything that's available here. For all the different kinds of headers or different kinds of packets. You can see those DNS ones are right there. And like I said, we're just, ICMP is ping, as I said. IP headers, you can see those there. Various other things. Radius type of radius servers. SNMP is there. Well, we will cover SNMP a little later in the semester. DFDP, X509. Certificate authorities. You'll learn a little bit about this in 350. And, even Zigbee's apparently. It's, I think a robotics thing or something like that. Yeah, if you guys have played with that. All right. So anyway, I'm just showing basically, just to kind of see the functionality of SCAPI. So we should be able. Let's see what we can try. Yeah, so we know the interface, right? So if I do, this is a Linux command, I'm sure. Interfaces. Yeah. So I guess, well, ENP0S3, right? That was our interface, if you remember. So what I'm going to do is I'm going to try to run that sniff command that you saw in the PDF, but from here, I just need to know the interface. So how do we do that? Let's try sniff. Let me see if I can figure this. All right, let's do this. So sniff. Then the interface, iFace. And if I remember correctly, it is ENP0S3. Okay. And then we need to specify the function that we want to do, right? So if you remember, what do we do with the packet that we captured? Here, I'm just going to use a lambda function. So these are common functions in Python. It's like I don't know how to describe it, but it's basically a technique so that you can quickly create a function. All right, so basically here we say, I'm going to use lowercase x. So x will be whatever the input is. And then that input is after the colon, we say what to do with it. So I'm going to reference that x. And I'm going to do .show, which is something of SCAPI itself. Yeah.
Is it possible you can move it a little bit?
Yeah. No. Give me a sec. If I do this, I think I can zoom in. Is that better or more? More?
Yeah. I just can't.
How about that one?
It was just hard to tell the difference if it's a comma or.
Yeah. Is this one good or more? That's good. All right. So we're at the bottom here. So I was saying we are in the SCAPI environment, the interpreter, and I'm just invoking that sniff function that we saw a second ago in the PDF. I'm specifying which interface I need to use. Now I did start SCAPI with sudo, right? So we should have the sudo or privilege. That's good, because otherwise this would not work in theory. I'm invoking a lambda function. Don't worry if you don't understand the lambda functions. Basically, as I said, it's a function that takes in X as an argument, and then we just show it, right? So, okay, so it didn't break. That means it's probably sniffing. Okay, so oh, there it is. So this is actually traffic in my background, right? So I'm sending packets of various things on this machine, on this VM, and it's effectively acting as a TCP dump kind of a thing. Does this make sense, guys? It just has its own formatting. All right, so it's 5:40. This was kind of a good introduction. So I showed you guys how to do the two VMs. You saw how to put them in that network. You get the IPs and ping from one to the other, and then you've installed Scapy, and we've just started to look at some of this functionality, like its own built-in packet sniffer. All right, so on Thursday, I'll pick up here where I left off. Keep going, plus we'll start getting into the bind9 configuration. Remember, that's your first main difficult Linux setup of a service, okay? So we'll meet again on Thursday, and then remember that the exam is a week from today. All right, so I'm going to